All right, so up next we have our training session, Closing the Security Gap in Learning. Our speaker for this session is Matthew McDonald, who is a tech author from Prost Tech. Matthew will talk about ways to prioritize security thinking when learning new technologies. Attending this session will give you complimentary access to one of 3 training courses. More information on this will be sent post-event. Matthew, whenever you're ready, you can take it from here.
Hi, thanks, Raquel. I think oh yes, here we go. Video started. All right, yeah, thank you. And thanks to everyone who's going to spend this next session with me as we talk a bit about the ways we learn about security as developers and IT professionals. Let me just throw this slideshow up here. All right. Share that. All right. Okay, so yeah, we're going to be talking about the ways we learn about security as developers and IT professionals, and how we can maybe start to close the gap between, the tech stuff and the security stuff. That's super important. Before we start, I thought I'd give a very quick introduction of sorts, so you know who you'll be spending the next half hour with. So let's jump back over here. Here's a little bit about me. I have kind of the perfect life, at least for a developer who likes to play with the latest and greatest new bits. For the past couple of decades, I've spent most of my time experimenting with programming languages and developer technologies and writing about them. My last count was 38 books, and that last count was quite a while ago. I've been an MVP, and that's still my home stack in many ways at Microsoft. But of course, I'm also all in on web standards like HTML, JavaScript, WebAssembly. And I've written for all audiences, from developers who are just starting out to experienced programmers, to little people who don't know that they need JavaScript yet. So this was a fun one. I wrote this one because I needed a way to teach my own children to write basic web pages in JavaScript. And I also have Young Coder, my tiny hot takes programming publication that's partnered with the good folks at Medium. So that's a snapshot into me. At Security Compass, I've had the chance to do something a little bit different. I'm still talking to my people, developers and IT professionals, but now the format is a compact kind of animation-driven training. You might have heard this talked about before. We call it JITS, for just-in-time training, after the way we can cut it up into little useful segments. And I've thrown up some random screen captures from some of our JITS so that you can have something to look at while I talk about that. And my focus at Security Compass is a bit different. I'm still talking about developer technologies, but now we're trying to think about how can you use all the new fun stuff responsibly? In other words, how do you keep a security forward mindset while you learn new languages, new frameworks, and new tooling products? So before we go any farther, here's a good time to stop, ask a little question, and think on that for a minute. So if you're a developer, how have you learned about security concepts in the past? And I'd also ask you to think about what's your approach to learning security when it comes to a new technology. And just to inspire you, I've put our Galaxy Brain meme up here while we think about that. I think for most of us, myself included, looking back, I can clearly see that security was sort of a separate domain that I studied. I learned about programming as a discipline, with all the testing, tooling, the way software and hardware works, programming languages, and then I dipped into security and the concepts in that domain on the side. And I think this is the usual pattern for a lot of developers, both for people starting out and even for seasoned developers that are just adding something new to their skill set. we tend to learn about the tech topics we need to get things done separately from the security concepts. The security concepts sometimes seem like a kind of unpleasant medicine we have to put up with. Or to put it another way, programming is some satisfying food you love. I'll put in chocolate cake here, which I love. Hopefully you do too. And the security is the side dish of vegetables that we push off to the side. But there are some understandable reasons for this divide. Developers are busy people. We want to get things done. We want to build features, check and code. We want to have clear deliverables. So we're always prioritizing learning practical skills. And this is what I see as the great divide between getting up to speed with the tech stuff and then learning the security concepts. That's too often, pushed into two separate domains. For example, let's say you're trying to get up to speed with something new. Let's say you're learning about Python. Your first goals are probably to set up a dev environment, import a few libraries, write some kind of a hello world test program. And the interesting thing is that security considerations can and should come into play for all of those steps, but that's really not part of the average developer learning mindset. Usually we just want to grasp how things work and get productive as quickly as possible. So how can we bridge that gap? I tend to think of these habits that we have. I call them security learning anti-patterns. You can also think of them as security learning avoidance strategies. And there's three main ones that I think we slip into all too easily. I know I'm guilty of this for sure. The first one is ignoring security except for a few specific topics. This is the phenomenon where we tend to think about security primarily around a few obvious topics, things like storing sensitive data or performing authentication. That obviously says security, but it's out of our mind until someone says passwords or someone says credit card numbers. And the rest of the time, we might be bumping up against potential security issues, but we're not focusing on it. And the problem here is that security is subtle, it touches every area where there's code. An example I like to think about is, if you've ever written a piece of code that could be compromised by a denial of service attack. If you think about a denial of service attack, nothing's being stolen, no one's sneaking in, there's no obvious data being compromised, the system is not being penetrated necessarily. But a denial of service attack can have all sorts of security implications. And it can be part of a chain of problems that makes a more serious, broader exploit. Just one example, maybe someone has stolen a password, but they use a denial of service attack to attack the part of your application that would ordinarily let the user reset their password, thereby extending the window of opportunity they have to exploit that password. So that's just one example where we might be writing a non-performant or unbounded piece of code that's exposed to a denial of service attack. We might not be thinking this is a security issue. So limiting security to certain topics isn't a good strategy. Another problem, another security learning anti-pattern, leave it for later. Basically, you ignore security as long as you can. And then you try to backfill the security stuff with warnings like, don't do this and don't do that. The problem is that by waiting, you've had plenty of opportunity to introduce security risk. And anyone who's gone down that road knows the painful reality that you can't test something secure after you've written it. You need to bake in security thinking all along the way. And my third security learning anti-pattern is sort of my favorite. This is the most comforting idea. Leave it for someone else. It's not my problem. I don't work in that security. I don't work in that department. That's security. I'm a developer. Let's leave it for the security team. That's in their job title. Let's leave it for DevOps. Let's leave it for the security champion in the dev group, and so on. The problem here is that you as a developer are making decisions today, and those decisions are going to accrue material and complexity. And if you started out on the wrong foot, it's really expensive in time and developer resources and testing resources to rebuild it. So, if you've been involved in sort of a later stage security review, you've probably seen this, that usually a lot of issues will be identified, a whole bunch of issues, and they can't all be addressed. They need to be triaged, and some aren't even going to be addressed at all, or maybe not for a long time. So leaving it for someone else is not a winning strategy. So what can we do better? How can we bring a security first mindset to our learning as developers and sort of close that gap just a little bit? I'm going to spend the rest of our talk here with a few ideas. I've got five basic ideas based on how we approach the content in our JITs that we write at Security Compass. So first of all, ask, how can I break it? The idea here is that pen testing is expensive, but security thinking is cheap. So we don't want to wait to challenge our assumptions until an application is in acceptance testing. Instead, ideally, we'll try to cultivate a more adversarial point of view to everything new that we're learning. So right off the bat, look for the places where something can be exploited, where something can malfunction, and then even ask follow-up questions. Say, if this fails, what else becomes possible? Because often security is a sequence of steps that in any exploit. These kind of questions start to close the circle and bring security ideas like threat modeling and mitigation earlier into the development cycle. And as we all know, if you address security earlier, you can do it more comprehensively and less expensively in terms of developer time and resources. And the old adage is true: security thinking is like a muscle. The more you practice looking through a security lens, the more instinctive it really will become, and the less signposting you'll need from your learning aids or from someone else. Eventually, you'll get your own instinct to spotting potential security points of concern. And really, that's what every developer should aspire to do, not just having someone representing the security champion on the team representing that domain. You want, as a developer, to train yourself to develop that instinct, just like you have the instinct into what sort of coding may not be a great idea, what sort of patterns may be not performant. You want to try to develop that instinct to, oh, here's something that could be exploited or could get us into a heightened security risk. At Security Compass, we're often thinking, what support can we give to someone who's experienced in general as a programmer, as a developer, as an IT professional, but might be relatively new with a specific technology? And in this situation, someone's not going to be able to implement or even remember pages of security guidelines because they're still, you're coming to a new technology for the first time. There's a lot to absorb. It's a fire hose of information. And if we're just dumping a bunch of security concepts in there, it's going to get lost. So how do we take what's important and make it stick? And one thing that always comes up with that is, it really helps to keep it practical. And here's an example I like to use. Probably everyone who has even the slightest exposure to security concepts has heard of things like cross-site scripting attacks and SQL injection attacks. These are really, really infamous security failings, and they're still pretty common, honestly, particularly SQL injection. But it generally happens with old code, ancient programming practices. And in the modern frameworks that you're learning now, you actually need to work really hard to make a cross-site scripting attack or a SQL injection attack possible. You have to go around the standard practices or sometimes the built-in protection that's in that framework. In I think pretty much every modern even a minimal, a minimal web framework will still have XSS protection. So things like top 10 lists of the most common security problems in the wild, those make for a fun discussion, but that's not the most practical thing. So it's not the thing that you're going to implement first on your own. And if you're not going to implement it, then it's just a bunch of security theory. And security theory still is useful, but that's the most difficult thing to absorb while you're learning a bunch of new information. So if you're focusing on theory and things that aren't practical, or aren't immediately practical, then as a developer, you're missing the chance possibly to really level up on security thinking. For that, you need concrete examples that you can apply to the tech that you're using currently, like right away, what you're currently learning. And I have an example about that, but first, I just want to mention one other reason why being practical is so important. Often security is a series of compromises. It's not just you have the insecure or you have the secure. Instead, you can't really separate that from questions about what is the risk and how valuable is this information? Where are we investing our developer capital? And are there side effects? Is there a performance cost? And are there other kinds of costs? And the only way to engage with all of those questions is to have a real example in front of you. Okay, so here's an example from our ASP.NET training. Now, basic security theory tells us that you must never store an encrypted password. Well, obviously you must never store an unencrypted password, but you never want to just encrypt a password, because then you have something that's potentially recoverable. Something that encryption could be broken. It could be, the original password could be retrieved. If there's a data breach or someone throws out an old hard drive without properly wiping it, sounds ridiculous, but that's been the source of common attacks in the past. So instead of just encrypting it, what we really want to do is we're storing password hashes, and when a user authenticates, we go through a whole process. We're going to remake a password hash and compare that to what's in the database, rather than encrypting the whole thing and storing that data there. All right, so that's the basic security theory. But with most pre-built implementations for user management, including the one that comes with ASP.NET, they're designed already around password hashes. So you don't need to worry about improper encryption practices at all. But here's a more subtle question. How do you stop people from using bad passwords or passwords that have been leaked in previous exploits? This question is a bit more interesting because it turns out that there are long lists of stolen credentials that combine the data that was retrieved in many infamous hacks. I remember there was LinkedIn is one that I remember in the past, where they, I think, stole a huge amount of user credentials. And people aggregate all of these password lists together and basically sell them on dark web parts of the internet. But good guys can use these lists too. So if you use Google, if you store passwords in your Google account, you've probably seen Google telling you, hey, it's time for a security checkup. So one of the passwords you've stored is not a great password because it's turned up in a previous data breach. So Google will check your passwords against ones that have been compromised. And ASP.NET developers can take advantage of a neat service called pwned passwords to do the same thing, to check if a password has, if it turns up in one of these lists of stolen passwords. And up here on this slide, on the left side, I have, just what, if you go to the pwned password sort of sample site, you can try it out, typed in a password. Oh no, this password, it was stolen before. It turns up in the database, not a good password. And on the right, I have something a little bit more interesting. This is the standard ASP.NET user registration page that they give you to sign up a new user. But now I've extended it so that when you enter a password, it's going to go check with pwned passwords, the service, and find out if that has been leaked in some way. And in this case, it has been. And so one of the error messages that pops up here is, hey, this password has appeared in a data breach. We're not going to allow it. I don't want to talk too much about the way that this works, but just to quickly sketch it out. It's kind of interesting because obviously you need a little bit of protection for the way you're going to be dealing with your passwords. You can't just send your password off to the Have I Been Pwned service, because you know, what if someone else is sort of pretending to be that service? What if that service is not really handling the password correctly? You don't really want to trust that by sending all your passwords through them. So there's a more clever sort of solution that they use. On your side, in the web application, you'll make a hash of the candidate password. You'll take the first part of it and you'll send that off to the service. You'll say, hey, I want to know, this is part of my password hash, just the very beginning. And the Have I Been Pwned service will reply with a list of all the password hashes that start with those same characters. So there'll be a bunch, because this isn't really enough information to identify the password. So in this example, hey, here are 600 hashes that might match the password you're thinking about using. And then on your side, in your application, you can compare this list to your full password hash, which you haven't shared with anyone, and see if there is an exact match. And if there is, you get one other piece of information, which is the number of times this password has been compromised. That's one of the other nice things about the service. It also works as a way to detect bad passwords, things like QWERTY and 123456, because those ones will definitely have been used by people who have been turned up in these exploits. So it's not, the problem isn't just password reuse, it's also just really, really common, really poor passwords. Both of those will turn up in these lists. And in my example, I think I tried this with a really terrible password. Maybe it was just password, maybe it was 123456. And the Have I Been Pwned service said, hey, this password has turned up over 3,000 times in our database. It's heavily compromised. You definitely don't want to allow anyone to use it. Now, the point of this whole example is that here is a practical security strengthening measure that you might decide to use. And if you do, it's up to you to add it yourself. It's not too hard, but it's not part of the basic framework support. So we're not just talking about security theory. If we were talking about password hashing and storage, well, there wouldn't really be an example, because ASP.NET already takes care of that for you. And there wouldn't really be much that you could really engage with. And odds are that a developer learning that is not really going to remember just theory that's not attached to anything. But if you go through this example, even if you decide not to use the pwned password service in your own website, you've had to engage with it more deeply. You understand the ways that these compromised passwords are recorded. You understand the way that password hashes are made. And you have the option to do something practical that's going to improve your security. So being practical is a really helpful thing in our learning, to just, we have a limited amount of time to learn something new. And so the time that you're spending concentrating ideally will be time that something will be sticky. Something will be information that you can remember and apply afterwards. So being practical is key to that. All right, another point is, I like to call it survey the landscape. And this is about learning where to look, even if you don't have the time to look there right at the moment. So if you're learning a technology for the first time, you're not going to be able to appreciate all the security requirements at first, but it's still important to know where these concerns are hiding. In our JIT training, we go out of our way to signpost, here are the areas that you're going to need to return to think about carefully from a security standpoint. So, you might not be able to internalize all that right away, but if you're working on a project before you're ready to sort of graduate it from one stage to another, from a design idea to something that you're testing, or from at that point, you want to revisit these areas and see that you've covered the security requirements. At the beginning of the presentation, I talked a bit about, what if you're learning Python for the first time? So in our Python security JITs, we say that, here are the things you need to know. Python libraries in PyPI aren't vetted. They could have accidental or deliberate vulnerabilities. And here's a tool, it's called safety, that you can use to vet them. You're not going to do that right now, but as you return to make more applications and start considering which packages you're learning, this is the risk and this is the tool. And so you've sort of signposted that in your mind. And one more thing, you should also use a virtual environment to deal with your dependencies. You don't want global packages. That's going to open the possibility of imposter packages being installed on the deployment machine. So here's sort of the basic hygiene you need to keep yourself safe, and you're still fiddling around with learning things, but these are the areas you're going to have to keep in the back of your mind, in your mental map of how security sort of applies to the technology you're learning. We really ran into this situation with Kubernetes, which is a monster of complexity. If you've followed it at all in news media, you've probably heard at least one famous hack or exploit involving Kubernetes being reported. It's happened to major companies like Aviva, Gemalto, Tesla. They've all been hit by exploits. And usually the problem is just seemingly minor misconfigurations, but just details that are easy to miss, because there's, again, an avalanche of information that you have to learn when you're dealing with a new technology like Kubernetes. So that's the value of a security forward tutorial. We can say, if you don't want to end up in this group of large, well-resourced companies, here are the topic areas you need to sit with and go back to, so you can make sure you've been smart about the security issues around them. So to take one example, in the Tesla exploit, attackers stole credentials to use with cloud services like Azure and AWS. And basically they spin up servers that will mine cryptocurrency. So you're paying for the compute time, they're getting the Bitcoin, an attack we call cryptojacking. And the problems at Tesla revolved around an optional administrative UI tool called the dashboard. So even while you're still learning about what the Kubernetes dashboard is and how to use it, this is obviously a really important danger area that you've got to bookmark in your mind. So right off the bat, we can say, well, first of all, we can say maybe you don't want to use the dashboard. Well, maybe you don't need it. But if you do, here's the basic hygiene: never give it elevated privileges, never let it run as a cluster admin, never expose it publicly on the internet. And these are the mistakes that, these are the practices that weren't followed at Tesla that led to this attack. Security learning isn't the difference really between being secure one day and being insecure, and then the next day you're secure. I mean, sometimes we think about that. Security is we're finding our security problems, we're fixing them, and now we've done our job. Hooray, security. But really, security problems creep into all the cracks of everything you touch, and making something secure is a process that will encourage a continuous sort of good security posture everywhere for your organization. Or, maybe a better way to look at it is, if you're relying on remembering security principles, then you need to get that right every single time that you're doing anything, whether it's creating infrastructure, writing code, you always need to get the security right. But if you build a process, then you just need to get that right once, and your process can sort of keep you honest from that point onward. And I think shifting our security weight from the what can I hold in my head to what can my process guide me and help support me is one of the critical shifts that you get into as you become more comfortable with security. So what do we mean with processes? I mean, it happens all over the software development lifecycle. Things like at the beginning, static analysis tools that examine your code or examine the libraries you use. It includes things like policies that you can apply in your continuous integration pipeline. So if a build breaches certain conditions, it's not allowed in production. When you're building infrastructure, it might mean a tool like Terraform that lets you vet your configuration when you're planning it rather than when you're applying it. You have a process to do that. You can automatically implement things like CIS benchmarks that are going to make sure you're not breaking rules of proper AWS, for example, guidelines, things like leaving open ports you shouldn't, or not encrypting things you should. And you don't have to remember all those details because you have something automatically checking this baseline level of security for you. In testing, and obviously the idea of processes obviously includes things like making unit tests so that you guarantee a baseline level of defense against careless mistakes. So you don't write the unit tests to make your code, to correct your code at first, because at first you're probably quite capable of getting it right? You're looking at it very closely. The idea is as you're working with it, revising it, there's plenty of opportunity for things to creep in. And often they're really, really minor, even mistakes, even typos, things that are easily overlooked, things that it's not a question that the developer, didn't understand it. They just are a human being that can be imperfect for a moment. And this kind of mistake, well, it can creep in, cause a catastrophe. But having a unit test there that just continuously checks, yes, that everything is still working the way you initially expected it to, is a really valuable baseline to prevent potential problems. Processes also includes things like regression tests, so that if you fix a problem, it's not going to return. There's a famous case with Apple when they released iOS 12.4. This is in 2019. It reintroduced a bug that had already been found and fixed in iOS 12.3. Even worse, because this bug had existed before, there were already exploits. Attackers could quickly adapt what they had, the exploits they had built for 12.3 to the new version, and have this exploit ready to go on the new operating system as soon as it was released. Now, had Apple written a proper regression test when they fixed the bug initially, and had that been running every single time, then this presumably wouldn't have happened. So, and the world is full of examples like this. There's another infamous one where there's like an extra semicolon that was in the code base, or an extra go-to line, and check was skipped, and it's always a very minor mistake. But unless we have these processes that are checking for these minor mistakes, we have these minor mistakes become major security problems. If big companies full of talented developers like Apple can make a sloppy security error, then obviously so can we. So the value of processes to help us support us and keep us honest is really, really important. All right, here's the last point that I want to cover. I already talked earlier about how the easiest bad habit for a security learner is to think security comes later. It's security is important. I'm just not thinking about it right now. I'm going to think about that after I get things working. Or maybe it's a design time consideration. Maybe it's a testing consideration, but it's not, I'm just coding now. I don't have to think about security. But even if you're just writing some simple scaffolding code to a pre-written specification, I mean, there are always security issues, potential security issues that you need to be thinking about. Are you preparing unit tests to protect yourself in the future so you can keep that baseline of correctness? Are you using vulnerability libraries in a known CVE database so that you can find if your libraries are reliable, are trustworthy? Even in your development environment, if you haven't really written a single or made a single build that's even ready to be tested, are you at risk for hard coding a secret? Are you inadvertently checking something into GitHub like a Azure or AWS key that someone could then steal and use for a cryptojacking attack? This is how most of these attacks work. They don't attack your application. They just have tools that scan public GitHub repositories looking for things that seem to be AWS or Azure keys. And if they find that checked in, of course, then they can exploit it. So even though you're not writing, you haven't compromised your system, you may be leaking important information. So security is not just a deployment time consideration or a testing time consideration or a design time consideration. It pervades all these aspects of the software development lifecycle. And so you need security measures. You need to address those through all aspects of your process. So we've covered a fair bit of ground here. In review, what do we have? How can I break it? Cultivating that adversarial mindset. So you're keeping that security hat on, and you're always looking at new concepts in a way of how can they be abused? How can they be a problem? That's a really, really good thing to train to get you to sort of level up your security thinking no matter what you're learning. Second, the idea of being practical. So if you can learn something about security that you can demonstrate and you can see implemented, that's usually worth a lot more than a bunch of interesting security theory. I mean, I love security theory. I like to talk about things like cryptographic algorithms and all that kind of stuff. But if we're trying to retain the most useful stuff about a new technology, we have to focus on the bits and pieces that we can implement and accomplish something with. Third one was survey the landscape. So you're not going to be able to internalize all the security knowledge at once. You're not going to be able to even understand all the security risks at first if it's something really complicated or really new to you. But you can still get that information about what the areas of concern are, and you can keep that as a mental note, and you can know what to return to. And then every time you return to that, you sort of flesh that out and understand a bit more how it plays into the security considerations of the whole system. So keeping that mental map and keeping track of the areas where you're going to have to look at is really important. Number 4, building processes to keep yourself honest and to support yourself. You can't rely on us fallible human beings to get everything right all the time. So every time there's a security idea, it should also come accompanied with the question of, okay, is there a way to automate this? Is there a way to implement this in a standard repeating way? I don't just want to see that I thought of security in one area and achieved it successfully. I want to make it so that it's a system that will protect me long into the future. And then just number 5, remembering that this applies to the whole software development lifecycle. So don't just think, okay, I'm relaxed now. I'm not thinking about security. I'm just, writing a simple test program, because every component of the system and every stage of an application has potential security considerations. And, whether it's, even if you're just in the design environment, you have to think about how you're handling your secrets. And if you're testing, how are you forming your test to look at things? So it's not just security problems or things that are designed into your system. It's a security mindset that you want to bring, that you can apply all the time. And really, it's helpful to think of ideas like that as a broader question of how do you encourage security culture in your organization. And the more you can do that, just the easier it becomes each time you return to it. So that might be a lot to digest, but I'm available by email if you want to reach out and continue the conversation. In the meantime, good luck in your own personal security learning journeys. I hope everyone enjoyed this chance to stop and reflect a bit on security learning. And yeah, I look forward to hearing from anyone, and enjoy the rest of the conference.
Awesome. Thank you very much, Matthew. I really appreciate that. There weren't any questions that came through the chat just yet, but like Matthew mentioned, if you have anything, please feel free to reach out to him directly, or if you want to reach out to us, we can pass on any questions to Matthew. Like I mentioned at the beginning, for those that attended this session, you will receive an email early next week, which gives you information on how to access one of 3 pre-selected training courses as a thank you for attending Equilibrium. And for those that are taking part in the Equilibrium Challenge, the training code for this session, and this is all one word, it is training22. So please put that in there and we'll get you some points at your chance at winning that Apple Watch. We are going to take a quick break and we will be back in just under 20 minutes for our SD Elements product demo. So use this opportunity to get up and stretch or grab a snack or a refreshment, and we'll be back shortly.